So let's start about programmable interrupt controller 8259 chip, right? So 8259 chip is called PIC chip, as you can see here. Now what is the use of it? As you can name suggest, it is interrupt controller. So now first question is why we need it. So as you can see here, if this is my 8086 microprocessor, we are having two hardware interrupts, NMI and INTR, right? Now NMI is vectored interrupt and INTR is non-vector interrupt. Now what do you mean by vectored interrupt? Now as it is written over here, when it is a vectored, then which ISR you need to call. Now I hope that you all know that what is ISR, interrupt service routine. So which interrupt service routine is called when INTA pin is active, that is fixed. It is always INT2, right? So we can't change it. So it is vectored, while INTR is non-vector. What do you mean by that? Which ISR to be called is not decided when this pin is active. So we can change it as per our requirement. So it is a flexible stuff. So normally in 8086 microprocessor, you can have only two hardware interrupts, right? As it is written over here. Now NMI is having higher priority, INTR is having a lower priority. So what if I want to give more interrupts? So in that case you require INTR pin and you can give more interrupt over here. And how to do that? For that you require 8259 chip. So that's why 8259 chip is required, because suppose your keyboard is attached with your NMI, your mouse is connected with this, and now if you want to use printer, then what you can do? So in that case you need to use something so that you can interrupt 8086 and you can serve your printer also. So this is the limitations of 8086, and because of that we require 8259 chip. Yeah, get it? So now see now what 8259 chip is doing. So as you can see in this figure, in 8086 we are having NMI hardware interrupt pin, INTR pin, and with this INTR pin, as it is non-vectored, as we have discussed, right? As it is non-vectored, now 8259 chip is connected with this, and with 8259 chip you are having IR0 to IR7, and so here 8 different devices can be attached. And what is IR0? Interrupt request 0 and 7. So 8259 will decide right that which interrupt is generated. It will tell your microprocessor will generate a signal and indicate 8259 chip that I am interested, and that is INTA bar. As it is active low, it will send two low pulses. It can be two zeros or two low pulses. On first low pulse, your 8259 will decide the final ISR number. So if IR0 is generated and which ISR I need to call for this IR0, suppose I want to call 44H, here my interrupt is stored, the code of interrupt is stored, then that number is sent in this second low pulse using data bus of 8-bit. Here 8259 will send the same thing to your 8086 using 8-bit data bus, that number. So the procedure is clear. Interrupt is generated, 8259 will tell your processor that interrupt is generated. If processor is interested, it will send the INTA pulse, two low pulse. On first low pulse it will calculate the address, in our case it is 44H. In second low pulse it will send the number to your 8086, and then 8086 will serve your ISR. Okay, so is use interrupt vector table and everything, and it will handle the ISR. So make one thing clear, 8259 is not handling your interrupt. It is not handling your interrupt. Interrupts are handled by 8086 only. Fine. Then what is the work of 8259? It is just deciding that which interrupt is generated and it is giving it to 8086. So the work of 8259 is providing more interrupts. That's it. Get it? So this is the work of 8259 chip. I hope this is clear. Now Before going to actual architecture of 8259, we need to understand the four properties of interrupts, right? So the first property is priority. We can decide the priority of 8259. We can decide the priority of 8259 as it is programmable controller, so we can program it, right? And as many time as we want, we can decide the priority of this interrupts, 8 interrupts which are attached with your 8259. 8259 can handle maximum 8 different interrupts. By default, IR0 is having the highest priority and IR7 is having the lowest priority. Clear? So this is by default, but if you want to change and you want to make the IR7 as the highest priority, you can do it. That process is called initializing 8259. So you can initialize your 8259 by giving command, right? By giving command, you can initialize your 8259 and you can change the priorities. Second is trigger. So which kind of interrupts you want, edge trigger interrupts or level trigger interrupts? So what is edge trigger? When the interrupts get active on edges, and level trigger, it will get active on level. What is the difference between edge trigger and level trigger? So in edge trigger, we'll see that pulse is going from 0 to 1 or not, and while level trigger, if it is 1, we'll use it. If we can take the practical example, suppose using your mobile keyboard, if you type S and continuously press S, you can't press S. It will only press once. So it will active on edge. Every time you need to do the procedure of finger up, finger down, finger up, finger down. Then only multiple time S will get printed, right? So that is edge trigger. On level trigger, if you take the example of computer keyboard and press once and just keep your finger on that S, then it will continuously press S. What that means, one that level 1 is satisfied, it is continuously working on that level 1. So only one time key press is needed, right? So that is level trigger. So this is the example of level trigger and edge trigger. Based on the both are good, like based on the requirement, you can utilize any one of them, right? There is no specific advantage or disadvantage. Based on the requirement, you can utilize. Like one example was given in one of the textbook was like if you are having a normal gun, every time you need to pull the trigger, so that is edge trigger. It will work on pulling the trigger. While in automated gun, once you have pulled the trigger, now you don't need to pull it again. It will work on level trigger. So these are the examples of edge trigger and level trigger. So you can decide that which trigger your interrupt will work. That is also possible. Next property is masking. So if you want to mask any interrupt, like suppose I want that anything comes on IR7, I don't want to handle it, I want to ignore it, then that is possible. You can mask as many interrupts as you want. So suppose you want to ignore some interrupts, you can utilize masking. That also you can do at initialization stage, right? Keep this word in mind, initializing, right? So you can initialize your 8259 chip. And last is vector number. You need to initialize your vector number. What is vector number? As I said, I am having IR0 to IR7 interrupts, and the code for this is stored at ISR. So I need to decide where that ISR is stored. So that need to be decided, that vector number need to be decided by user, right? I want to write down the code of IR0 at suppose 44H, then I need to write down the code at 44H, and I need to tell my microprocessor that it is stored at 44H and this will be stored at suppose 48H. So I need to tell my processor that the vector for this interrupt is stored at this location and interrupt service routine for this interrupt is stored at this location. So this I need to decide, and this is done by user only. Fine. So these are the four properties that you can utilize with your 8259 chip. Fine. Now the question is, initialization is compulsory? Yes, it is compulsory. Now why it is compulsory? Let's check priority. If you don't set the priority, default priority will be used, right? So it is not needed. Trigger, anything is used, we don't hardly care. Masking, if you don't use masking, all are unmasked by default, so that is also not compulsory. But if you don't give vector number, your microprocessor will get the garbage value, and in that case, if I have a interrupt for keyboard, and it is possible that it will run the code of mouse, right? So on garbage value, it will not get the proper coding and you will not get to serve your interrupt well. So that's why you need to initialize your vector number compulsorily. So initialization process is compulsory and it should be done because of this vector number, right? Now need to initialize all vector numbers compulsorily. We are having 8 different interrupts with your 8259, right? Then it is compulsory to initialize all 8. No, if you initialize only IR0 as 44, by default it will take IR1 as 45 and so on. So you need to initialize at least one interrupt service routine and then it will work. So this thing is compulsory. So get it. So what we have concluded from our discussion is using 8259 you can handle maximum 8 interrupts more, right? So this is possible. But now what if I want to handle more interrupts than 8? I want more interrupt to my microprocessor, right? 8086 microprocessor. I want more than 8 interrupts. Then what to do? So in that case the solution is called cascading. You can use cascading. So if you are having a 8259, here instead of attaching any hardware device you can directly attach another 8259, right, as it is attached here. And with this 8259 you can attach all other devices. So what that mean, in this case this is called cascading, and here the first 8259 chip will called as master and this will called as slave, right? So with one master you can attach 8 slaves, fine. And with each slave you can attach 8 different hardware devices. Yeah, so what that mean, I am having 8 slaves and with each slave you are having 8 hardware device. So total 64, 8 4 8 8 are 64 different interrupts I can attach using 8259. This is the maximum number of hardware that I can attach as interrupt to my 8259. So 8259 can handle maximum 64 interrupts using cascading, right? Now why not more? Why can't I attach more IR like 8259 chip here and go on? Is it possible? No, that is not possible. Now why that is not possible? Suppose this is my first 8259 chip, right? And with this I have attached different number of slaves as we have attached before. And with these slaves, if I have attached more slaves, as you can see here, but in this case this middle one will work as master for this slave and it will work as slave for this master. So same chip will work as master as well as slave. So that is not possible. Then chip will get confused, like I am slave or I am masters, and functionality of both are different. So that's why this is not possible. You can only go with single cascading. So maximum 64 interrupts are only possible. So what is the work of 8259? To increase the number of interrupts, fine. And that's why we are going to use it. Now we'll see the architecture in next session. Thank you.